In this video, we're going to work on division of decimal numbers. For the most part, there's absolutely no difference between dividing by decimal numbers and dividing by whole numbers. So you want to do this. That statement is true if what you're dividing by has no decimals. This just means do 9 into 7.2936. Take this decimal, put it above, and now ignore the decimals. Don't see the decimals. 9 does not go into 7 even one time, so 72. I ignored the decimal. 9 goes into 72 8 times. I subtract 72, I get 0. I bring down the 9. So now this number here is just 9. 9 goes into 9 one time. I take away 9 once again. I get 0. I bring down this 3. 9 does go into 3. Not evenly, but it goes in 0 times. 9 times 0, I subtract, I get 0. I bring down the 6. 9 goes into 36 4 times. That's 36, 0. That number on top is my answer. 7.2936 divided by 9 is equal to 0.8104. I had the decimal, I put it right above, and then I ignored it. In other words, I did 9 into 72936. In fact, you can do it this way that I'm going to show you. Just ignore the decimal completely. 9 goes into 72 8 times. 9 times 8 is 72. Subtract, get 0. Bring down the 9. 9 goes, this number here is 9. 9 goes into 9 exactly one time. You subtract, you get 0. Bring down this 3. That number is 3. 9 goes into 3 0 times. 9 times 0 is 0. Subtract, gets 3. Bring down the 6. 9 goes into 36 4 times. Now, you can, if you like, you can come back and put the decimal where it was. Just for the record, if the decimal was elsewhere, if the decimal happened to be here, I'd happen to put it up there. But it wasn't. The decimal was right here, so I put the decimal right there. The next problem is 42.3142 divided by 3. That means you do 3 into 42314. Now, whether you put the decimal there or not, initially, it doesn't matter. But if you put it here, just put the 1 above. Now, if you like, don't see those decimals. They're not there. You're mistaken. They're not there. 3 into 4 goes one time. Subtracts 3, get 1. Bring down the 2. 3 into 12 goes 4 times evenly. You subtract, you get 0. Bring down this 3. 3 does go into 3 one time. You get 0. Bring down the 1. 3 goes into 1 0 times. Get 1. And, just to make this work out nicer, let's make that last digit or 5, please. Let's make that last digit a 5. We bring down the 5. 3 goes into 5 5 times. You subtract the remainder 0. Now, if you like, you can put the decimal where it was. It was between the 2 and the 3, and then put it up there. You can even put the decimal in at the end. The division is not different. Don't let the decimal bother you at all. Just because I did put the decimal there, I'm going to redo the problem without the decimal. 3 goes into 4 one time, subtract the 1's 3, get 1 left over, bring down the 2, 3 goes into 12 4 times with remainder of 0, bring down the 3, this number is now 3. 3 goes into 3 one time, 1 times 3 is 3, I subtract, I get 0, I bring down the 1, this number is now 1. 3 does go into 1 0 times with 1 left over. Bring down the 5. 3 goes into 15 5 times. Oh, yeah. This was a decimal problem. The decimal was here, so I put it up there. Don't let the decimal bother you. And if it is, not a big deal. Do it. Put the decimal in at the end. The decimal's here, put it right above. The one thing that you have to be careful about is if you don't put the 1 right above the 4 and the 4 right above the 2 and the 3 right above the 1, etc., you're gonna have trouble. I mean, if you write 1 4 1 0 5 and the decimal is here, well, you know, is it here? Okay, you need to be neat about that. You need to put 1 digit above. There's a digit above the 4. It could have gone in 0 times, so there wouldn't have been a digit. And there's a digit above the 2, and there's a digit above the 3, and there's one above the 1, and there's a digit above the 5. You line them up really nicely, you won't have a problem. The decimal's here, so I put the decimal there. You start putting 2 digits above the 4. You start putting multiple digits above the 4, like 1 4, and then 1 0, and then 5. Well, of course, when you bring up this decimal, it's going to come here. Okay? Be neat about it, and decimals won't affect anything. Now, I said that these problems are exactly the same as regular long division if you're dividing by a whole number. Well, what if you have this problem? Now you're not dividing by a whole number. So, what you're dividing by 0.9? Well, oh my. What can I do to 0.9 to get it to be a whole number? The answer is to move the decimal to the right. So now it's 9. Oh yeah, I remember. If I move one decimal number, if I move the decimal in one of the numbers, I have to do the same to the other number, the top number in this case. I move the decimal 1 place to the right, so now I have to move the decimal 1 place to the right. Now it becomes standard division. 9 into 7321. I won't even write down the decimal. 9 times 8 is 72. Subtract, get 1 left over. Bring bring down the 2. 9 goes into 12 one time, with 3 left over. Bring down the 1. Oops. Bring down the 1. 9 times 3 is 27. You subtract, you get 4. Put a 0 in. Bring down the 0. 9 times 4 is 36. Subtract, get 4. No number, so it's a 0. Bring it down. 40 again. 9 times 4 is 36. Subtract, get a 4. Bring down the 0. Okay, I hope it's clear that the 4 is repeating. And when it repeats, you put a bar on top of it. Okay, now this was a decimal problem. When we were dividing by 9, the decimal was right there. Okay, I'll put the decimal right there. There it is, 8.134 bar. That means 8.1344444444 forever and ever. Okay. Let's suppose we were up against this problem. 3214.251 divided by 30. Now that's even a whole number, and you can do it. But who likes dividing by 30? Again, understood the decimal is there. If I move it to the left one place, then this will be 3.0, which is 3. So now I'm dividing by 3. Oh yeah, I moved the decimal to the left one place in the bottom. I have to do the same to the top number. So this is the problem that I'm going to do. 3 into 321, and I'm not even going to write the decimal. If it bothers you, don't write it. If it doesn't bother you, write it. 3 goes into 3 one time. You take away a 3, you get 0. Bring down the 2. That number is 2. 3 goes into 2 exactly 0 times. You subtract, you get 2. Bring down the 1. 3 into 21 goes exactly 7 times with no remainder. Bring down the 4. 3 does go into 4 one time. So I subtract 1, 3, I get 1. I bring down the 2. 3 goes into 12 4 times with no remainder. Bring down the 5. 3 goes into 5 one time. Take away the 1, 3, get 2. Bring down the 1. And 3 goes into 21 7 times. Let me put that 7 up there. And now I say, oh yeah, there was a decimal between the 1 and the 4. So there it is. Done. Done. If you wanted to put this decimal here at the beginning, then you should put it right above and then ignore it. If that bothers you, put it in the end. Even if your teacher says you're not allowed to put it in the end, how is your teacher gonna know when you put this decimal here? Unless your teacher is watching you when you do your homework or when you're doing an exam, teacher won't know when you put it there. Besides, it's not his or her business when you decide to put the decimal. Suppose you have 72.18 and you want to divide by 3,000. My goodness, 3,000 is a 4-digit number, but we can make it into just 3 by moving the decimal, which is understood to be there, 1, 2, 3 places to the left. 3.000 is 3, and that's what I'm dividing by. I moved it 3 places. I better move the decimal in the other number 3 places in the same direction to the left. So This is the division we're doing. 3 into 0.07218. Now, when you have a 0 at the beginning, okay, when the decimal is at the beginning, you really need to put it. Okay, that's the only time when you don't have to put the decimal in. If I multiply this number by 10 over 10, then I would get 0.7218 divided by 30. Then I can deal with not putting the 0, okay, the decimal. But putting the decimal at the beginning is not in the middle. Just put it, be done. 3 goes into 0, 0 times. I subtract 0, I get 0. Bring down the 7. 3 goes into 7 2 times. I subtract my two threes, which is 6. I get a 1. I bring down the 2. 3 goes into 12 exactly 4 times, nothing left over. Bring down the 1. 3 does go into 1 0 times with 1 left over. Bring down the 8, and 3 does go into 18 6 times. Other than putting the decimal at the beginning, nothing big. Okay, that's the answer to that problem. It was a lot easier than doing 3,000 into 7218. It was a lot easier. I promise you that. You don't want to divide by 3,000. Divide by 3 instead. Okay. Let's do another problem that involves a trick that I taught in the shortcuts to long division. If you have 28.314 divided by 1.25, most teachers would say, okay, move the decimal 2 places to the right. You get 125. Move the decimal 2 places to the right, and you get this. And then do your long division. Do your long division. But that's division by a 3-digit number. I don't want to do that. So I take the beginning problem, and I remember that 125 times 8 is 1,000. So we'll multiply the top and the bottom by 8. Now 1.25 times 8, well, 125 times 8 is 1,000, and I move in 2 places. Or I say that's about 1. That's exactly 8. So the answer should be around 8. 10. 10. Okay, so the bottom is 10. And I have to compute 28.314 times 8. So I'm just multiplying by 8. 32. 8 times 1 plus 3 is 11. 8 times 3 plus 1 is 25. 8 times 8 is 64, plus 2 more is 66. 8 times 2 is 16, plus 6 is 22. So I get 226512. Now 22 is around 30. 8 is around, say, 8. So I get around 240. The decimal goes there. But now here's the beauty. Let me write it down a little bit bigger. Here's the beauty in this. I can easily be dividing by 1 by moving the decimals 1 place over. And dividing by 1 don't have to do. So the answer is 22.6512. Okay. I multiply 2 numbers by 8. One of them you should know. 125 times 8 is 1,000. And the answer should be really 8, around 8. So it's really 10. So the whole job was really, in my opinion, was to multiply this number by 8 and then move the decimal in one place. That's a heck of a lot better than moving the decimals 2 places to the right and then dividing by 125. Okay, I multiplied by 8, which was less than what I was supposed to divide by. I mean, I'd even be willing to multiply by a number bigger than this, than divide by that number. But I actually got to multiply by a single-digit number versus dividing by a 3-digit number. Okay. Now, suppose you have 32.415 divided by 5. Now, this is not the worst. You can do 5 into this number. In fact, if you prefer, don't even put the decimal. 5 goes into 32 6 times. That is, I take away 32 left over. Bring down the 4. 5 goes into 24 4 times. You subtract, you have 4 left over. Bring down the 1. 5 into 41 goes 8 times. So I take away 40. Bring down the 5. 8 goes into 15 3 times. And I go, oh yeah, the decimal was here. So I put it right above. And that seems about right because 5 times 6 is 30. And this is a little bit more than 6. So 5 times more than 6 should be more than 30, just like that number. Okay, what I would do instead is I would multiply by 2 over 2. I would take 32.415, and instead of dividing it by 5, I'd multiply it by 2. And I would get 64830 divided by 10. And then I'd move the decimals in one place. So now I have 648 it's 64.830. 64.830. I move both decimals in one place, and then I would get 6.830. And that 0 at the end is unnecessary. So instead of dividing by 5, which isn't the worst, I multiplied by 2. I want moving the decimal to be effortless. Just move it one place. Move the decimal one place. The top number is this, and the bottom number is now 1. And the rule for dividing by 1 is don't bother. There's your answer. Okay, which is exactly the same answer we got up here. That 0 doesn't need to be there. It could be there. Doesn't matter. Okay, so you can use the shortcuts that I pointed out in my video on shortcuts in division to do division problems involving decimals. Okay, because the decimal isn't in the way. Dividing by 5, you can also double the top and then divide by 10, which means to move the decimal. Okay, this finishes division of decimal numbers.